Hello everyone, this is Devansh Kaushik and Abhilekh Talukdar presenting our VCC project for the topic Management of Virtualization Technologies with Complex Event Processing. So, the problem statement involves the real-time pattern detection for multiple application platforms. There has been an increase in data due to diversity and variety and volume of data. Uh, so, this problem statement tries to tackle this critical issue of automating the streaming of data using Docker containers, plus upscaling and downscaling the resources allocated to these containers using the complex event processing model. So we would be aiming to create actions to increase or decrease these resources in accordance with the use of these system resources. So coming to our processing module, complex event processing module, we'll be using Docker as a and Docker Apache Kafka to publish or subscribe the data that is coming from these Docker containers. This data will be both kinds of data, the streaming data and batch processing data, and all of this data would be fed into the Kafka. Then Apache Flink will be used. So Apache Flink is a complex event processing library. So it would be getting all of this data, and the data analytics would be done, and patterns will be detected on the basis of the input, and whatever. If the system detects a pattern, then it would give the alerts or notifications on that basis to increase or decrease or downgrade the resources that we have. And all of this would be implemented on the cloud, and we would be maintaining a persistent time series storage for the same. So coming to the tools used, we would be using Docker Engine. So to maintain the status data of the containers, the data would be real time, and the data that we would be maintaining would be the time, network usage, and the parameters of the data we are sending in order to detect those patterns. Apache Kafka, the publish and subscribe system, PubSub system, would be used for transferring the data to Apache Flink. And whenever the module detects a pattern, it will produce a warning, and it would be given as a alert or a notification to the Kafka topics. Then we coming to the programming interface, we will be developing a UI interface for the end user to check the constant results that are coming ahead, and the notifications and the alert that we would be publishing. So it is based on a distributed system architecture which provides the appropriate actions according to the rules. So it would be downscaling or upscaling them on those rules. Handing it over to Abhilekh to discuss the usage scenarios.
Hi. So I'll be discussing the first usage. I'll be discussing two usage scenario. First one, let us assume that there's a rule which indicates that for 80% memory limit, 90% CPU usage limit, we make certain changes in the our system in our deployment. So let us assume that this action is set to increase the resources for both memory and CPU so that the functions which are being carried out are carried out smoothly. So whenever we in the data, whenever we see a pattern which is conforming to this rule, like whenever we see a pattern which is satisfying this rule, we take the action corresponding to whatever happens when this rule is satisfied. So basically, what we'll do is we'll increase the memory and CPU resources on the container via Docker engine. Coming to the second scenario, let us say that there is a rule which requires the initial allocated memory and allocated limit to be reduced, and this rule is triggered when the memory usage is less than 10% of the allocation limit. So this rule we have created just to maintain our so that our resource is not wasted. So we need to decrease our resources which are being spent here. So if the container status which matches pattern indicated in this rule, Then we move forward and generate the output and push it onto the Kafka topic. And when this message is received from Kafka topic, it decreases the memory allocation limit via Docker engine. Moving on, how we will for the evaluation part, our goal is to run a test that assesses how well the system performs as the system loads increase. And for this, we aim to test the system under like 3 to 4 different loads, like 10 events per second, 100 events per second, 1000 events per second, and so on. So, when the quality of messages sent to the system increases, we keep a log of the latency under the different loads. So, we hope that the findings can demonstrate that the message, as the message load rises, the system performance rises as well. So, through the test that we will be conducting, we will try to answer a few questions. First of which being like, what is the behavior of the system against the increased message load, and how the reaction times of the submodules on the system change in response to the increasing message load. So that is all we hope to achieve in our project. Thank you so much.